So we've got Sam Crossland here, who's a Gearset DevOps architect, right? He helps talk about all things DevOps, and really share how some best practices around this. And this sort of started, just funny enough or randomly, I saw this, I think it was your session poster on LinkedIn, right? This kind of like clip here. And
Yeah.
I was like, we use the code analyzer internally. I just like slapped it together, very rudimentary style, just so that I could get it to work. And it would have been, I thought to myself, it would be really cool to see a session about it and just learn more about Code Analyzer and some of these CI/CD processes because I'm not a DevOps expert. And I know there are other people that know it a lot more than me, like yourself. So that's kind of how this came about. And I'm super excited to have you here. I appreciate your time as always, spending it with us and the community. So yeah, please take it away, and we're all really excited to learn from you.
Great. Thanks very much, Warren. Yeah, just like you said about being kind of a DevOps expert, for full transparency, I started in the Salesforce ecosystem around 3 years ago. I'm not a Salesforce developer. I do have a development background. I've worked in C# and Java, more so in scripting languages. So I have a lot of experience in kind of PowerShell and Python, and that's where the DevOps angle kind of works very nicely for me. So thank you so much for having me on here. As Warren said, this is the session that I ran back at TDX in San Francisco a few months ago, and then also an upgraded version a couple of weeks ago at TDX and World Tour London. And it just focuses on what is Salesforce Code Analyzer and how you could integrate it into your CI/CD pipelines. So as Warren said, I'm one of the DevOps architects at Gearset. Gearset is the kind of all-in-one DevOps platform to handle everything Salesforce. But my main role is to actually work with customers on a more consultative nature. So how do I implement things? How do I make everything talk to each other? Maybe we do some kind of scripting and GitHub Actions or Azure pipelines. And this is where this kind of span up. So in terms of what I wanted to chat through today, so that's me. Everyone can see me. I've done the intros for myself. The agenda for today's session, this should probably last about 20-25 minutes. And as Warren said, feel free to pop some questions in the Zoom chat. And I've got some resources at the very end that I can send out as well. We're going to touch on what is Salesforce Code Analyzer. So objectives, capabilities, why you would use it and why you should use it, especially as developers early on in the kind of life cycle of development. We'll touch on some of the CI/CD stages to leverage Code Analyzer. So that's your continuous integration and delivery stages, normally in the source control realm where we're raising pull requests or we've got branches with a load of code in them. And we'll use the DevOps Infinity Loop, which is everywhere at the moment, to highlight how that fits in. I'll talk through some of the existing CI integrations. So they're things that exist both from Salesforce themselves. They've got a team that push the GitHub action. And then there's also some other capabilities in the community that have been written. That leads me on nicely to the kind of side project that I started last year and now is all released, which was in Azure DevOps. There wasn't a plug and play mechanism to get Code Analyzer running against your pull request. So that was a custom extension that I've gone and created and is now live. So it's very plug and play. That's the kind of demo. But I've integrated into the demo for this audience around starting off at the IDE stage. So in VS Code, there's also a number of different extensions like Agentforce for developers and Code Analyzer that makes it really nice to be able to scan early on. Then we'll go on to some considerations and limitations alongside some interesting finds I had of using Code Analyzer along the way, and then finish up with some key takeaway and resources, which, as I said, I've got a little pack to send out. So first of all, what is Code Analyzer? Why would we use it? What are the capabilities of it? So overall, it's a unified, customizable static code analysis built specifically for Salesforce development. So obviously there aren't generic items out there like PMD, for example, that covers a lot of different languages, but Code Analyzer has hoovered all of those together, and we can see on the architecture on the right-hand side, the engines across the bottom where we've got PMD for things like Apex, we've got ESLint and Retire.js for the JavaScript components, and then the version 5 that came out a few months ago is also bringing in things like flows and regex. So it's a nice unified area to do our static code analysis. Everyone's probably seen the term or heard the term shifting left. but this is focusing on that as far left as possible. So it's allowing us to run things in the IDE when we're developing new code, but also at the early integration stages in our source control system. I think it also works quite nicely to support in the code review process. We've probably also seen when there's massive pull requests of hundreds of lines of code, normally people might cynically say, this looks good to me, and kind of not give as much attention to the detail. So this is where some automated tools like Code Analyzer can be really nice in supporting that. It is very extensible. So as of the version 5 release back in April, you've now got a centralized YAML file where we can have things like custom rules, we can have tagging, we can override severity. So it's much more powerful than version 4, which has been around for a little while. And you also get much nicer reports now. So the HTML report, we'll see that a couple of times in this presentation, but you've also got JSON outputs, the Sarif files, which I know you use internally. They've all been bumped up in terms of the level of information that they provide. So they become really powerful for sharing and tracking your code quality over time. So where would I be looking to leverage Code Analyzer? And this is where I wanted to use the DevOps Infinity Loop. So we've probably all seen something like this, and Salesforce have the kind of thinned down version that's only got these 5 stages: plan, build, test, release, and observe. So the first stage is really in build. So that's where you might be using VS Code or a different IDE like IntelliJ. We can integrate Code Analyzer into there to be finding problems before they even get near source control and quashing them nice and early. The next couple of stages are in test. So that's really where we've got it into source control. We're starting to deploy it through our various Salesforce sandboxes. We need to make sure that we're catching and blocking, so gating against those problems as much as we can. And also in that final observe stage. So I think quite a lot of teams get apprehensive over using code analysis because we're afraid of all the technical debt and the hundreds or thousands of issues that are going to crop up on an old code base. But it can be really, really useful just to have some knowledge there and allow you to start prioritizing that backlog work. So a few different stages we can add that into. Some of the existing CI/CD integrations for Code Analyzer. First of all, we've got the IDE. So you can install the Salesforce CI into the IDE to run specific commands. And you've also got the Visual Studio Code extension or plugin to be able to analyze as you go, which I can show shortly in the demonstration. So you can run that on save. We can run it against wildcarded subdirectories or on particular files. That gives us really local early results for developers before we get near source control. And there's also a couple of areas that we can partner with. So Apex Guru is part of Scale Center in Salesforce, where we're focusing more on performance-based items, but there is part of the extension to kind of quash anti-patterns early. So like SOQL queries in loops, for example, things like that. We want to be keeping those out of our development. And obviously, we've got to talk about AI. So Agentforce for developers is in there. You can ask Agentforce for developers for advice on code or generated test classes, and it will also automatically offer you items, just like Copilot would do, but with a Salesforce twist and focus there. So I've got a couple of screenshots. With the new version of Code Analyzer, which is version 5, it is a dedicated plugin. So we can see it's, this is an older screenshot. I think we're on 5.2.1 now. Distinctly different from SFDX Scanner, which was the old version 4. We can see down here that then you can use various commands. So I'm running against all of my classes, for example, it will go off and grab the relevant engines that I need to actually scan the items in there. You can see there's a lot more engines in there than there is in Code Analyzer version 4. Then we can have an output inside the CLI. So we can see we've got several hundred violations of various severities across all of my Apex classes here. Or I could have pumped that out to a Sarif file or a JSON or a HTML file as well. There's a couple of key settings. So turning off Code Analyzer version 4 from the extension is important because that will be retired in August. And as I said, version 5 is much more powerful. And you can also enable things like Apex Guru to look at the more performance-based items. The actual automatic scanning is also relevant. So we'll see it a little bit here where I'm hovering over a particular method and it's saying we've got a severity 3 and 4 issue by Code Analyzer. And the quick fix elements will use Agentforce for developers to offer me some options about how I can fix those. So quite a lot of power in the IDE and locally. When we talk about moving into our source control system, so let's say we're using GitHub, for example, there's probably a couple of stages you want to be running this, like I said, on the life cycle. So first of all is around the pull requests. you would usually need some custom script padding to only run the scan on the Delta files. So that was a big kind of downside, in my opinion, that if we changed, a couple of files in our pull request, we'd actually scan the entire branch worth of classes, which is obviously quite redundant if we're not interested in the technical debt. We're really interested in the pull request. So the Delta of files becomes important there. But when you are interested in the tech debt, the scheduled one-off runs on an entire branch is very, very useful. So Salesforce have developed a GitHub action for the full branch scans. And as of a couple of weeks ago, I actually only updated this about 2 hours before the demonstration at World Tour. There's now a PR review summary where they've updated the action to say, this has introduced 9 more issues on top of the 100 that already existed. So it does split out the delta versus the existing items. You get some advice on linking it up with DevOps Center if you're using that for your CI/CD deployments, or custom integrating it with other scripts as well. So a couple of screenshots here. This is me setting up the YAML file, which is actually controlling our code analysis that we've got. And you can see I've got a number of other YAML files on the left-hand side. But the key bits on this screenshot are I've set this to say we can call it manually using workflow dispatch. I also want it to run every day at midnight, so I've got a regular set of runs against an entire branch, but also any pull request raised against my integration or hotfix branches, I also want to trigger this process. So you can be really specific, especially with Gitflow, about when things are triggered to make sure they're running. We can then see from the history of this that I've got my scheduled runs, I've got some pull request runs and manual runs. So you get in GitHub, you get that nice history of the actions actually running. And then when you dive into the details, we can see I've got like a HTML artifact that I can then download here and use and view over a longer period of time of all the results from that scan. And then the new piece of capability that came out, as I mentioned, you get a nice comment now that says we've got 400 violations, and including 8 in the files changed by this pull request. So then you get this nice little breakdown on the right-hand side. You're not having to trawl through to see out of the 477 violations, which ones have I added. You're getting that split result there in GitHub. So then I came to actually wanting to integrate it into Azure DevOps. So from my role here at Gearset, there was customers that I was talking to that wanted to integrate Code Analyzer into Azure DevOps, but there wasn't any, as I said, community tools or plug and play options for it. So how did I kind of go ahead and do that? I really like Azure DevOps, but in some ways I saw it as very awkward. So there are a lot more prerequisites and oddities when you're setting something up in Azure DevOps compared with that kind of simple YAML file that we just saw there in GitHub. There's not really anything else you need to do in GitHub, but there are quite a lot of hoops to jump through in Azure DevOps. We can tie it up with something called branch policies, which allows us to quality gate particular stages. So that means if my code analysis scan at my QA stage doesn't pass, I don't want to allow that pull request to merge. So we can really, have some tight blocking there. I started off this kind of about a year ago, and then it went a little bit quiet towards the end of last year and picked it up before the TDX presentation that I did. It started with a couple of 100-line YAML file to get this working as I wanted to. But a few months ago, I actually packaged that as a proper extension. So now it's much more plug and play. You can go on the Azure Marketplace just like you would do from a Visual Studio Code perspective if you were looking for an extension, and install it into your org and get that running nice and easily. So we'll talk through that a little bit more in the demonstration. So these were some of the awkward bits I just wanted to highlight. So with GitHub, you get 20 agents by default, I think, that can run in parallel. But with Azure, you have to actually request via a form, and it can take several business days for them to give you one active runner, which feels very redundant and not great in this kind of day and age for you having to do that. So that took me a little bit of time to kind of get my head around as to why there wasn't just a runner available for actually running these YAML files. And then next, you need to make sure that you only get 1,800 minutes as well by default. So the minutes isn't too important when we're talking about code analysis because things should happen in kind of 30, 60, 90 seconds. But obviously it can be important in terms of the parallel jobs. So because you only get one parallel job for free, if you've got a high velocity team raising tens of PRs a day, they will all queue up. And then we get obviously a performance bottleneck there. So something to consider around those. The first version of this as well, I found a couple of interesting bits. So there's a organization-wide backend setting that says trigger my YAML pipeline for any pushes to any branch across the entire repository. So obviously that's super wide, and that's not going to be what most customers actually want. So you can go in and override that to make sure it only triggers on particular items like a pull request or pushes to a specific branch. You can do that in the UI. And then there's also a second section where shallow fetch is turned on by default. And what that means is we only retrieve one commit's worth of history where we're doing a Git checkout. So that doesn't sound too bad, but when we're talking about pull requests and we actually need to be doing accurate Git diffing, we want shallow fetch to be off. So in the first version of this, in the blog that I wrote, I said, right, go in and change all these in the UI. But now it's actually much easier where you can just do it with a couple of lines of YAML. So at the top there, we're saying don't trigger on anything, and we'll handle the pull request triggers with the build policies I mentioned earlier. And at the bottom, where we're checking out the GitHub repository into the runner, we actually want the fetch depth overridden to say, give me all of the Git history. So obviously, that could have some performance implications for larger repositories, but it makes sure that the diffing we do for the pull requests is actually accurate. Great, so now we get to demo time. And if I just switch over to my other screen. So if everyone can see that okay, I'm in Visual Studio Code. I've got a set of classes open here on the left-hand side. I've got those extensions installed, like I mentioned. So if I just go to the extension section, we've got the Salesforce Code Analyzer. There's an extension here with its relevant settings. We've got the Salesforce CI installed. We've got Agentforce for developers, which is that AI component as well. So there's a couple of cool things that we can do. So this is in a branch that's already in a pull request. So that's Sam's questionable Apex changes. So we can see that I could either run things at the bottom with the Salesforce CLI, just like normal. So if I go up a couple, I could use SF Code Analyzer to run against a particular, I could run against all the classes if I want to. So I can use wildcards in this instead of having to say a very particular file, and that will just give me the results in line. It's going off and working out, what are these specific issues across all of the class files in there, and we found 89 total. But if I'm interested in this file, for example, using right click, I can just go to the SFTX scan current file with code analyzer capability because of the extension. You can set this to automatically do it on opening the file and saving the file. And then we get those violations down here in the problem section of VS Code. So we can see we've got 11 problems with this particular item with various severities that are called various severities that we might want to focus on as a minimum. If we take this bottom section here, so I've just got this empty method, which I think I was testing like a PMD avoid empty methods capability here. But you can see that we've got a hover capability and we've got a severity 4 and 3 item here where we're missing Apex comment and the instance name doesn't match a particular regex via the PMD engine. But using Agentforce for developers, I can say, oh, actually fix that Apex doc issue for me. And then it spits me a description out. Obviously, there's not tons of logic. There's no logic in that method. But if we had a lot of logic, that might save quite a bit of time of having to actually pump a description out. There's obviously automatic capabilities and things like Copilot. This isn't anything new, but that's the Agentforce for developers context that's allowing us to do things like that. And you can see my problems number is now thinned down to 10 as well. There's another interesting bit that I wanted to outline. So this is the actual meta XML files that sit behind Apex classes. I think it's something that most teams I work with will kind of just leave in the background unless it comes up. So these are the API versions that are tied to your Apex class. Obviously, the Salesforce sandbox versions get bumped every 3 or 4 months. We get the releases. We're currently on version 64. So with a new engine in Salesforce Code Analyzer version 5, this will now accurately detect for you whether you're using a really old API version that you probably shouldn't be. So for example, we've been told here that it's more than 3 years old. So really we should be bumping that to a later version. Obviously that might kick up a little bit of regression testing that we need to do, but it's still a very valid item that should be taken care of. So if I just bump that to version 64, we can see the problems will reduce down again. So I fixed a couple of issues here. As I said, it's already on a branch where I am ready to go. So if I just go back and see that I unfixed these changes earlier. So I will change this to say fixing the SFCA changes. So that's pushed up into my branch in Azure DevOps now. And if I just shoot back to here, so this is a pull request that I've got open from that branch that I was just working with into a different branch that's got my code analyzer YAML file set up. And we can see we've just queued an extension to run, which is the code that I mentioned that has been created. So we can see that a couple of hours ago, I had 42 violations detected on this pull request, and that will become important once this extension starts running. So we've got a number of files that have changed in here. They're all class files, and one of them's that meta XML file that I mentioned earlier. So we'll let that extension actually go and kick off. And we can see here that it's queued waiting for a runner to become available in Azure DevOps. So if I just move on, I've now got another pull request, which has only got XML file changes in it. So I want to raise a pull request for this one just to show that as part of the coding that I did on the extension, there are certain file types that the code analyzer still doesn't work great with. So that's flat XML files, for example. Yes, the regex engine might grab some things, but really we don't want to be booting up the full analyzer, installing the CLI and the plugin and running the code analysis if we haven't got any relevant files. So I've let that, I'll let that run and I'll show you the bit of kind of fail fast methodology that I've put into there. So this is the actual YAML file that sits inside Azure DevOps, and this is what's going and doing all the work for us. So this is the custom extension that I mentioned that you would install from the Azure DevOps area. You get lots of nice capabilities in terms of parameters. So do we want a hard fail if we detect violations? Do I want to work on only one severity threshold and above? So if I only have sev 3s, 2s, and 1s, maybe I want a hard stop on those. We have the file extensions that we want to scan, so that gives that capability for you to be able to add other things in. If there are extensions that become available for certain rule engines in future, you can add those into there. And then this was something that I released last week, actually, about posting comments onto the pull request. So do we want to stamp a comment on so that other reviewers can see exactly what's taking place? This is the build policy section. So in Azure DevOps, this is the area you would come to say, if any pull requests target this branch, so let's pretend this was my QA branch, for example, I can say in a build validation section, every time anyone raises anything, kick off a particular pipeline, which is that YAML that I've just outlined there, give it a display name, and say, is it a required policy that has to pass? And that blocks anyone kind of circumventing the process and being able to merge things that they shouldn't do. So if I now shoot back to my original pull request, we can see Azure DevOps decided to queue for us, and we can see that that has now finished. If I dive into this result here, we can see that we've got an error. There was 2 violations found above the severity threshold of 2 that I outlined. And I can dive into the job and see exactly what's happened. So I won't go into all the nitty gritty of this, but we basically grab all the parameters, we work out the git diff of exactly the files that have been changed, and we store those as an artifact. The bit that takes the time is then installing the Salesforce CI version and the code analyzer package. That's a majority of the time just to install those 2 items. We then let code analyzer run against that entire workspace, and it goes off and determines which engines it wants to go off and grab. It tracks the number of violations that are in there, and then we go through the custom logic to say, did we want to fail on particular number of violations or only certain severities? And then we get the final results here. So you can see that I've now got a comment stamped back onto my pull request, where we've now got 41 violations. And if I dive over to the published artifacts for that particular job, we get a HTML and a JSON file. And we also get just a copy of all of the files that happen to be in that pull request because we use that as our workspace target. So in the HTML, it's then much nicer for me to be able to come in here. This is the HTML that has been spat out from the report. I could look for particular engine issues, particular severities. You know, I could thin it down to say, I'm only interested in Sam's Apex class, Sam's example Apex class. So it's much nicer than the very static report you got in version 4. And obviously then you can keep this as an artifact to work out trends and do things over time. So if I just shoot back quickly to my second pull request I raised, which was the XML portion, All I wanted to show here is that the first pull request that actually scanned took about 1 minute, 10 seconds. And as I said, the majority of that was installing the CLI and installing the code analyzer plugin. This one finished in 4 seconds because the first bit of code says, are we in a pull request? Are there any relevant file extensions that we even want to scan? No, so we fail fast. We don't need to go off and grab the CLI and install it and everything else. So that's just a fail fast mechanism to make sure we're not wasting minutes and over scanning things that aren't currently relevant. So that brings us to the end of the demonstration section. If I just shoot back to the deck. So I wanted to kind of finish up towards the end with considerations and limitations of both Code Analyzer and the extension that I've created. So first of all, using Code Analyzer, I've talked quite a lot around using it at the right time and the right place. So the right engines, where you run it in the life cycle, we want to be running it locally in VS Code while you're doing development so that we don't end up having to, have a report in our IDE that says we've pushed some problems. We want to quash those as early as possible. On the pull request, we should only really care about the delta. So only the changes that we've made, they're the ones that we want to report on and make sure are in the right pull request context. But branches, you might want to be monitoring your technical debt. So maybe we do a full branch scan on master every night to track the number of violations that are in there across the whole. And hopefully we'd see that iteratively come down if you're working on tech debt to be able to reduce that. So the results are an interesting one. We showed the HTML report, but who analyzes it and who needs to be notified? So does the ownership go back to the original developer to fix the problems, or does it go to a lead developer? Do the issues fit into an existing user story? So if you've got a 2-day user story and you've got 14 violations to fix, do you actually need to spin up a separate ticket and to fix that? And then how do you store them and progress them over time? So they are just point in time snapshot reports. So that kind of pushes it onto you as the owner to say, how am I going to scan this over a longer period of time? There are a few limitations, I would say, with Code Analyzer as well. So there are some blind spots where we're talking about developing Visualforce or Lightning components. If we've got some embedded JavaScript in there, or we're shooting out to a third-party library, it doesn't handle them great, if at all, because it normally just works on the file extensions. And that's why I focused on that with my demonstration. And there's also some formats and metadata types skip. So they recently introduced flows, for example, and there's a couple of rules in there, but it's not going to grab all of the metadata types that you might be working with in Salesforce. I already mentioned over the longer term, you need to be the person who grabs the onus to track the trends and analyze those reports to make sure that we're hopefully on a downward trajectory. And it's also usually scanning the full files rather than the delta. So just even with the GitHub action improvement they made, you're still getting the full reports. It's just thinning down to say you've introduced some problems from these 8 files. So there are some drawbacks to consider. In terms of my custom extension that I showed, there's no pre-built runner. So as I said, a bulk of the time, it's normally 60-70% of that runner time is spent on installing the Salesforce CLI and installing the Code Analyzer plugin, because we go off to NPM, the package manager, to be able to grab those. So I have considered, and it is something that you consider, whether you use maybe a maintained runner, so a custom Docker image where you could do that. And Salesforce actually have one, but it has the old version of Code Analyzer in it. So I did a bit of a weigh up and thought a fresh VM and task would make sense here. Pull request trigger versus the full file scan. So currently there's no one-off scans in there. That's something I've kind of got on my roadmap. And we're also not only scanning the delta lines. So if you change 2 lines of a 100-line Apex file, we'll still get the results of the 100 lines of Apex. So if you've got a load of technical debt in there, they will still crop up. So there is a bit of post-analysis that you still need to do. Some improvement options, allowing one-off scans and then line-by-line PR comments. That's something that I was thinking about. That centralized Code Analyzer YAML file where you can be really custom about things like severities and tagging and false positives and all that good stuff, allowing use of that from a config directory. And then also some customizability over the engines and the output files, because at the minute we leave it up to Code Analyzer to work out which engines and rules it should run, and then we spit out the HTML and the JSON file. So plenty of things that could improve with it in future. There's a few interesting finds that I had along the way. So one of those I just mentioned, if we don't pass a specific engine to the Code Analyzer, CLI command, it runs very, very quickly because it dynamically works out which engines it needs to run depending on which files it's been told to scan. But it is only using the recommended tagged rules from that YAML file. So it's not every PMD rule, for example, it's only the ones that Salesforce have said are recommended. So if you want a bit of a broader check, it will take a little bit longer and you'll have to specify the engine. I've talked about shallow depth, so this got me for a good few hours originally about why was my Git diff looking a little bit weird, but we need to make sure we get a large amount of Git history back, especially in a big repository that's got a load of pull requests going on. And for anyone that's working on App Exchange development, so if you're doing things like second generation packaging or you're developing managed packages, the PMD App Exchange rule set is not the same as the PMD rule set. There are a lot more aggressive rules in there for second generation packages. And if you're running on the metadata API repository format, which is the older form rather than SFDX, there's also, you need to do more work because you need to set up that config file to make sure it detects the right extensions. So just wrapping up with some key takeaways. The first one is around version 5 evolutions in Code Analyzer. We're ensuring code quality and maintainability throughout the life cycle. So it's not meant to just be a one click and done capability. We want to instill it into multiple areas. You get those really nice reports to analyze and monitor the trends over time. We get some big wins in version 5. So you've got the new engines like regex and flow. You get the central YAML file where you can do things like overriding severities and tagging, but you still have some blind spots with JavaScript in Visualforce and running on full files. So just something to consider. The right tool and the right stage, we want to catch those issues early and shift them left. But you can also think of integrating it into the wider testing strategy. So you might be using SLDS for the Lightning components. Maybe you're using Prettier and Apex Guru in various other parts of the life cycle. And also think of it in term with your unit regression and UI testing capabilities as well. So it fits in nicely into your entire suite there. In terms of ADO, it was possible originally when I did this with that custom YAML file, but now the marketplace extension makes it even easier to just one click kind of install, set up that thin down YAML file, and everything else is handled in the background. So with ADO, we've kind of ticked off another source control system alongside GitHub where Code Analyzer is nice and easy now to get installed. Just a little quote that I wanted to kind of finish up with is that kind of success in DevOps isn't just about speed alone. I have a lot of conversations around stability as well. So it's making sure we're delivering reliable, secure, and maintainable code from the beginning. So that's why we want to be catching things at various places of the life cycle. And Code Analyzer partnered with your source control system kind of acts as that gatekeeper. We don't want to allow things to get into master and production and then become just another number in the technical debt assessment. So we want to make sure we're grabbing them as early as possible. So this is the kind of final slide. This is the QR code to a little craft document that I set up with a load of resources. So obviously I can send this to you, Warren, and to everyone afterwards, but if anyone wants to grab a screenshot or anything of that, then they can do. There's a few interesting bits in there. I've got a lot of links out to Salesforce documentation, also a comparison table between version 4 and version 5 of Code Analyzer, and links to the Azure DevOps extension. So I think that wraps me up, and I'm happy to take any questions or if there's been any in the chat.
One, I'll have to say, like, this is some really slick stuff right now. And so, if you're in Cloud Code, you know that we currently run some of these processes. And once you submit your assignments for review, we're currently using version 4, which we need to upgrade to version 5. And that was, a big thing for me coming on here, seeing some of the differences, seeing how it is implemented. So, just like off the cuff, right? Thanks so much, Sam, for going over this stuff. It's very interesting, very timely for a lot of the things that we are doing inside of Cloud Code. So it's great to hear different ways of getting these things done and the improvements that are going on there. And yeah, we'll definitely take the resources. I'll share them out with all the folks in here as well. And I think there's a few different comments, but maybe now we have an actual question from Eddie. Eddie, number one, my boy. No, I'm kidding. We got a question from Eddie for App Exchange / PDO. You mentioned briefly about second generation packaging. What about first generation packaging for those who avoid second gen? So I guess it's what are the differences between those?
No,
Can you explain?
it's a very good question, especially because I think within the last week or two, they have now released a migration capability to go from first generation packages to second. So obviously the push is to move towards second. You can still use Code Analyzer to, if you're building a first generation package that's going on the App Exchange, it's still recommended as a part of your readiness review before you submit that to Salesforce. And it is an artifact that you can send alongside them. The second generation package items that I mentioned were much more around the actual repository structure. So obviously the SFDX repository structure allows you to do subdirectories and subsections of your application in a much more granular way than the old MD API format style. So I think a lot of the rules are more based around that SFDX structure and everything pushing towards second generation packages. But if you're doing first gen, you can still use it as part of your readiness review.
Awesome. Really cool stuff. And just for kind of backing it up a little bit too, because we have people at various different levels here, right? It's for the app exchange, right? The different applications that you can install that are vetted and pre-built inside that you can bring into your Salesforce org. So pretty much every time or any app that is on the app exchange needs to go through this process of being verified, vetted by Salesforce, and to be put up there. And the security review process that they go through, it runs a lot of these checks and automations that we're even going over now. So it's good to understand how to do these things if you're trying to eventually thinking about building an application on top of the Salesforce platform. And so that's one piece of it around App Exchange stuff, but then there's also the piece for your internal code where this is really good to have as part of your process to understand, or I'll say make sure that you're following best practices, right? That Salesforce picks up
Yeah.
and follows as they're running. So yeah, really cool stuff. And it's important because I know we have a lot of developers on here and we're asking like lots of questions around, I wrote this code. Does it look correct? How do I know if it's right? All of that stuff. Some of it can be caught when you're running like the Salesforce code analyzer, right? As it starts processing through.
Yeah. And I didn't show the much of the Agentforce extension capability, but obviously you've got things like autocomplete. It can automatically generate you test classes as well. Obviously, that's still something that you would want to make sure your coverage is as expected and it's got the right business context of what you've created. But yeah, Agentforce developers will hopefully keep improving because I know there's people might still be using Copilot or using Claude or other AI systems. And I know that Salesforce are pushing Agentforce has got all of the context to make it the best partner in the VS Code area.
Yeah, I think that's key is the context piece, right? If once we can give it access and information about our org or about Salesforce best practices, because sometimes you have to feed that stuff into the other agents, right? Because they're trained on so many different languages.
Yeah.
So if you feed those best practices in there, it will do good. But if Agentforce for Developer can really start to pick that up automatically and already be trained on it, that's going to be, key for it. Um, awesome. Yeah. Any other questions, comments? Feel free to unmute. If it can be just a comment, right? If this stuff is going over your head, that's fine. When I first started, this stuff went way over my head, but as I continue to learn more and more, you see the usefulness of it. So yeah, feel free to, leave any comments that you have, any questions that you have, and we will do our best to answer them, whatever you got. Slightly over my head, but learning. Love it. I got a question from Tyler. You mentioned
Yeah.
feedback on performance in addition to addressing errors. Is that a metric that the analyzer would give feedback on for best practices? So, yeah.
It's a it's a good question. So the performance angle was more Salesforce released something a few years ago called Scale Center, which is more around in your production instance when we've got all of our code running. in Salesforce, and our applications are built and with end users, you can use Scale Center to see whether there's any performance bottlenecks or issues with things like querying a load of information or our loops. That's where the performance element comes in. So there's a subsection of that called Apex Guru, which focuses more on Apex to say, have much more of a performance spotlight about the code that you're creating. So just because, for example, we're doing SOQL queries in a loop, that's not a security violation. It is definitely a performance consideration. So that's where Apex Guru, if you ticked that in the VS Code extension, you'd highlight those kind of things. It's still in beta, and I think it will be for the next several months. And you don't get as much context as when you run it actually in the Salesforce production instance, but that's the performance angle, is focusing to make sure you're writing performant code, not just from a security and best practice perspective.
Cool, cool.
So I can see,
Oh,
yeah,
go ahead.
I can,
Do you want me to read it?
I can see one
How do these things
reference.
work?
I can see one reference to the Gearset nemesis that is Copado. Do you think this will work well with Copado, or should I focus on running these tests prior to promotions? So I think I'd go back to the slide where I showed the DevOps Infinity loop, where you should definitely be running it prior to the promotions in your VS Code instance, so that you've got those early results. I would always want this as a multi-layered approach. So once you get it into source control, like I showed where I raised the pull request in Azure DevOps, maybe we want the scan to run again, because then that's very visible. We've got an actual artifact spat out of it that's stored in the source control system. It will definitely work with Copado, but it will be integrated into your source control system rather than Copado directly. Salesforce also releases something called Testing Center, which is a little bit of a wider capability and can integrate things like kicking off UI tests and other testing platforms alongside Code Analyzer. So I think there is a bit of a tie up there, because Copado is on platform that can use things like Testing Center. So there will be some integrations. But I suppose, yeah, the short answer is we should be running it in a multi-layered approach locally and in your source control. So it will definitely work with if you're using Copado as your CI/CD tool.
Very cool stuff. I'm curious about the output that some of these will generate, right? So you talked about the artifacts when you're going through and running these inside of GitHub, ideally on your pull requests or whenever you're actually running them. So right now, and you probably saw in the Cloud Code one, we're getting that Serif file, and then that will kind of outline in your pull requests some of the different areas and surface those values that have changed. Have you, or those recommendations that it's giving, really, have you seen any like benefits for like using the HTMLs versus the Serif files versus the what was the other one that got produced, like the XML that will
JSON,
spit out the
yeah,
JSON one?
you can do. So I was just double checking on the page. You can do CSV, HTML, JSON, Serif, or XML. So normally I would see Serif is super useful where you're in a source control system like GitHub that will natively render that for you. I didn't go down that route because another awkward as your DevOps thing is that you'd have to have an extension or a paid add-on to natively render the Serif files.
Mm.
So that's why I didn't go down that route, which is amusing considering Microsoft own both of them, but they've definitely got
Yeah.
some feature disparity, should we say, between those two platforms. So I'd see the HTML really useful, especially if you're sending it to maybe senior stakeholders or off to a generic security team that just want a snapshot of the artifacts. The JSON and the CSVs and the XMLs, if you're piping those into external systems, maybe you're using something like Splunk or you're aggregating all of your logs somewhere more centrally, having something in a JSON file might be much easier to then go and pass and render somewhere else if you've got a central dashboard. So there certainly can be very useful. You can pipe out more than one file at the same time. So it's still just a one-line command, and I've said, give me the HTML and the JSON. I don't think you could do that with version 4, from what I remember. I think you'd have to do it separately. But yeah, you can grab all of those out.
Very cool. Yeah, I mean the Serif file is super helpful in our specific situation because students are working on this stuff. They throw in the PR, it then outputs the different lines, the different areas for improvement. And for anybody that's going through Cloud Code, right, there is a GitHub's folder, or it might be like the .github or .workflow. There is a file that has a YAML inside of it, a .yaml file that goes through all of the different steps that run when you submit a pull request, right? When you submit your assignments. And if you're just starting out, it's fine if you don't want to read through it or don't understand everything that's in there, but take some time to read through and do some Googling, do some chat GPTing to understand like some of the steps that are going through there because it can help you just build out and understand more things that are going on in the developer space. Right. So
Yeah.
yeah, really important stuff,
If
really
I
fun stuff. Yeah, go for it.
Sorry, if I just steal the screen one time, just to show that also, obviously, VS Code has got an inbuilt Serif viewer. So you can also do this
Mm,
locally. So if you're used to seeing things in Serif, you can. I've just ran one command here, which is to output that run from earlier into a Serif format. Then you can just command click to open that on the actual viewer on the right hand side. So if you're much more used to viewing things like on a per rule basis or digging down into the actual locations, you can do that in a Serif file in VS Code.
cool. I have not seen this before. That's awesome.
Cool. I think there was another question in the chat. So that's how important is it to learn YAML for DevOps and differentiating whether you're a Salesforce developer or Salesforce DevOps? You might be doing both. It's a very, very fair question. And certainly some of the teams that I work with, especially smaller teams, as you've said, they might actually be very multi-hatted. They might be doing Salesforce development on the platform. So they might be actually writing Apex classes and triggers and doing other things that need to happen in their production instance. But they might also wear the hat of a release engineer or a release manager to actually progress those changes through different cycles. So I'd say from a purely DevOps perspective, YAML is pretty crucial because a lot of the source control systems use it, and it's just your way of being able to dictate what happens when, and it's pretty standardized across the different source control systems. I would say if you're a Salesforce developer rather than a Salesforce DevOps developer, it's normally DevOps engineer. So we probably get into a few terminology differences. Um, as a Salesforce developer, you are developing on the Salesforce platform. You might not necessarily have any input or even care about how that progresses through your sandboxes and gets into production. We're just developing that application. Whereas if you're a DevOps developer or an engineer, you probably much more care about that latter piece where it's like, are we doing our unit testing to a correct percentage? Are we progressing things as quickly and as stably as we should be through our sandboxes? So I'd say you're still a developer, and that's why I classified myself at the beginning saying, oh, I did a lot of PowerShell and Python and automation-based things. I'd still classify myself as a developer, but not an out-and-out on the Salesforce platform building applications level developer.
Yeah, I think that makes sense. I'll chime in on my experience here too. I've worked at various different companies and worn some or all of those hats. Maybe not specifically for a DevOps engineer, but take for example my last company, which was at Blackthorn. We had a specific person who was a DevOps engineer, he was a release engineer, and he handled all of that, all of this stuff. And all we needed to do as part of the dev team and the engineering team was submit our code into our pull request, and we would see, the violations and all of that stuff come back. I didn't have to really worry about the .yaml files or anything like that. But in a previous life, when I was heading up the development team, I made it a point to start to integrate some of this stuff into the overall dev team's process. Right. So I made it a point to say when we are committing our code, we're going to run code analyzer in pull requests that are coming through. So I had to learn that stuff as a dev lead, right? And figure out the YAML files and all of that stuff. Whereas the rest of the dev team, unless they were super curious, they once again just needed to submit their code and see the violations come back or anything like that. So you will wear multiple hats depending on where you sit on that spectrum and what your job entails. So it can be important to learn, especially if you're on small teams, because you're going to wear all the hats. But then as you get to larger teams, there may be dedicated people for that kind of job. Cool. Awesome questions. Anything else to round us out? Any final questions from anybody before we sign off here? I'll give it another second. All right, I'm seeing thank yous coming through. So, yeah, Sam, we
Thank you very much.
appreciate your time being here and going over this stuff. It's super interesting, even if it's going over my head and some folks' heads. We're gonna rewatch the recording and just start to just learn more, absorb it. Our vocabulary is growing, and it's all just good stuff from there. So, yeah, we appreciate you. Thanks so much for jumping on and just sharing this knowledge with us.
No worries. My absolute pleasure. As I said, I've got all my contact details in that resources pack that I sent out. So feel free to drop me any questions about any of this, and happy to help.
Awesome. Cool, cool. Well, I think that's all we got, folks. Appreciate everybody being on here for this first style of, I guess, webinar and bringing on some really smart folks. Hopefully, we will do some of these more in the future. So appreciate everybody's time for hanging out and those questions that folks asked, and we will see you on the next one.